is an amazing speaker and also a very good developer, obviously, but he's very good at explaining things to people, like explaining shit like you're 5. So this is going to be really fun. He's going to tell us how to recreate a Node.js runtime, which is really interesting. So please welcome Erick.
Can you hear me? Hello, my friends. How have you been? So sad. How have you been? That's the energy. Today, I'm going to show you some mad science, some crazy ideas I had, like recreating Node.js from scratch. So this was part of my own research. I hope you like it. But if you see something here that is contradictory, let's chat after the whole talk that we can talk. Well, I came all the way from Brazil. I hope I'm better JavaScript developer than soccer player, right? If you can, please take pictures of the event, mention me, mention this talk, because this helps us a lot with the work we've been doing here, all right? First of all, this talk, these examples, everything is already on the internet. I'm going to share the slides with you at the end of the presentation. But if you feel like any slides is good, you could take a picture and share with your friends as well. Please, don't forget to mention me when you're using the presentation as well. Well, I'm working with Node.js, using the Node.js core, and I was able to help on a very nice bug in the Node.js. So this was like a really checkpoint of my life. I really like it. But I felt like I had a lot of help from other contributors there. But I was like, I'm not sure if I know deeply this. So after solving this bug, I gave a lot of talks showing the journey, like the step-by-step, how I create the pull requests and everything to finally release the version. And I finally became part of the Node.js organization. I was nominated there. This was amazing. But in the same time it was good, it was, you know, that feeling like, oh my God, there's so many good people working there. I should learn more and more thing. So I started creating on my YouTube channel now a lot of other mad science ideas. Like, what if I wanted to implement a WebSocket from scratch, the whole socket protocol without any frameworks, without Socket.io? Or what else? How can we create a code cover tool? Spoiler alert, is the CDP that Joanne was just showing. So I was thinking, do I really know Node.js? Do I really know all the components? V8, Libuv, all this vocabulary, it's so, sometimes it seems to be easy to understand, but for me, I wanted to see in practice. And still, I felt like I don't know so much, right? So I started researching, and I found a lot of the docs, and sometimes some docs were contradictory. One talk says that V8 does one thing, other says that Libuv does another different thing. If you're not familiar with these words, I'm going to show you in practice how this works as well. All right? So I noticed, like, for me, the only way to really make sure that I learned is to create from scratch, to create without any libraries, any frameworks. It's kind of mad science, right? But it's, for me, it's a good way. So I started researching. I found out the V8 website. I found out some ideas. But the best place we can find of how people created, how was the first commit, was looking at the docs, right? Looking at the Node.js, and I found these very nice resources showing how the event loop timers were working, but it was all theory. I wanted to see how it actually was working behind the scenes. So this talk is about this YouTube video I made. This is a step-by-step there that you can follow. I prepared the whole environment, but today I'm going to bring some highlights, and you can go and master in any interview about Node.js, about how it works behind the scenes. And actually, you can think about how other programming languages are working too. But as I was saying, this is just my research, right? I'm not a C++ developer at all. I did a lot of workarounds just to make this work because I was trying to learn a lot. A lot of the code snippets I'm going to show you today is in C++, but never mind the language. We're going to see how the APIs, how the things are being called, and you're going to find out how this works. And as I said, this is part of my own research, my own trial back and forth. And I hope everything is right, but if it's not, let's chat about later and we can discuss it. And just a shout out for all JavaScript runtime authors and contributors. After doing this whole research, I start to value it even more, because we are only able to use JavaScript today because someone was there doing the whole abstraction for us, so we don't need to go deeply and handle memory, handle pointers, and so on. And let's do some magic, all right? So everything recreating Node.js. When I talked to some friend, they were like, you are crazy. When I talked to some Node.js developers, I was like, you are on Node for so long, you should know, right? I have no idea. I was like, yeah, this is gonna be a tough task. So the first thing I did was to go on the Node.js repository there and find out the v001 branch to see how Ryan Dahl first implemented. And I was browsing, and I found a lot of files there, and I noticed ATP, the file system, net, and a lot of other models just came in the first version. And there, I was just clicking in all of this to understand and how I could try replicating. But remember, it's 14 years ago. A lot of the APIs that they're using here, it doesn't work anymore, right? Even like Libuv that I'm going to show you later was created after those first versions. So this is pretty nice. And this was the first website of Node.js. Is there anyone that saw this website before? Oh, this is very nice. And see, they're not using console.log. It was puts. Oh, very nice. Well, for you who never saw the Node.js, like how it works behind the scenes, I'm going to explain you about the V8, the Libuv, and the C++ bridge that I've heard some people saying, but I've never understood. First of all, V8 is just the JavaScript grammar. So we have eval there to run some script. We have const, function, and all JavaScript data types, all right? We have the Libuv, the event loop, everything that is asynchronous, everything. Reading a file, calling an API, everything that goes out of your code, everything that you might have a callback, you can use Libuv there. And Libuv has also an event loop, which look like a while through, just checking if there is any event pending, and then you can dispatch them all. And the whole glue, the bridge, is C++ in Node.js, for example. Let's take an example here. Imagine we have a JavaScript file, right? And we have the global this, the global environment in JavaScript. Imagine we just compile the V8 library in C++, and we want to extend it, right? So I'm using print. Print doesn't exist in JavaScript, okay? So what I'm gonna do, in C++, I'm gonna implement a new function, and look how amazing is it. Now I'm gonna use the V8 API to see every time you call this keyword, execute this C++ function. So this is gonna work for all Node.js modules. Everything that is asynchronous, we usually use this. Let's go further. Let's try using setTimeout. SetTimeout doesn't exist there as well, so we can implement a function in C++, and now see, I'm using the UV API, right? Because it's gonna be asynchronous. It's gonna be another dependency that's gonna handle all events for me. And then when I put this, you can see that we can have on the global this there. So process.env, it's also added by C++ and a lot of other variables as well. So, Node.js is actually a tool that extends everything, right? It's the C++ code there that is just glue them all. So you might see that we are not JavaScript developers, maybe. We are C++ developer in the end. I don't know. There's a lot of, it's crazy, right? Because it's all abstractions. I've seen people saying to Java developers, Java is not good. Node.js is not good, but in the end, it's the machine code, it's the C++ working. All right, the best way to see how everything works is in practice, right? So let's see how the Node.js is working behind the scenes. This is part of also my tutorial there. And I'm gonna show first the index. So here is where I initialize my program. It's like our index.js that we have there. I call capybara, or capybara maybe in English, which is a very common animal in Brazil, so I brought some references, right? So there, see, there are a lot of code. Never mind this code. Let's just go step by step. Here, I'm executing a code, and see, we are reading a file. It's a file name, so I get all the JavaScript string, all right? I put this JavaScript string on a variable. I then compile. This is the process to map all the JavaScript context to C++ instances. So in the end, we are executing C++, and after it, we're gonna execute like an eval. We run this code, and if you want, you can print it later. It's exactly the same thing I showed you on our diagram. And then I wait for events. That for now you don't know what is this, but it's the Libuv while loop, right? That I showed you on the diagram as well. Nice, and see, I'm using here this code I just copied from the V8 examples. In here, I'm not using Libuv. I'm using C++ read. Because the first moment is to actually get your file, right? So this doesn't need to be asynchronous. But when I'm reading files, usually I need to get some file and say, oh, I'm going to wait for the operating systems. I'm going to keep responding clients. And then when I have the answer, I'm going to call you back. So now we have a lot of ideas, right? How it works behind the scenes. Well, this was actually the hard part for me. I spent months trying doing this. So I have to get the V8 compiled. I have to compile the Libuv, which is C++ libraries, and I need the binaries. And I made this make file. And you see all the C++ headers and everything I want to use on my C++ side. And then, see here, I'm not a C++ developer, right? I don't know tooling about C++, so I'm using Node.js to watch for all C++ changes and just execute and recompile my code. So let's see this in practice. So I'm going to use make to compile. Now I have a new binary. And see, I'm saying, get my binary, get my file, this binary. So I'm just reading and executing the print I just made there. Pretty interesting. So what if we call a console.log? This, for me, was mind-blowing. Let's check this practice. For the console.log, I'm executing here, and see, I don't have anything. It's something like, it didn't show any error, but it's still, I don't see the console there. However, if I try using my console on an object, I can see the object there, and if I can see the keys, I have the same API that we have on Node.js and in the browser. Well, it turns out console.log is an internal thing. It's the environment, right? On C++, we usually use printf. On browser, they could use however they want, but on Deno, they can implement as they wish. So for me, it was like, oh my God, this is so nice. And did you know, set timeout, set interval, and console, they are not JavaScript. This was like, oh, this is something really, really interesting for me. So let's check this out, how in practice. So now when I run here on V8 from scratch, you can see set timeout is not defined. What else? If I do the same thing for interval, I don't see it as well, because set interval and set timeout are external functions. However, we have a standard pattern, we have a standard API that we can use, and they were defining, but there is nothing about the implementation. It's just, oh, when we have a console.log, you should print to the std out. When you have an error, we go to the std error as well. So let's go deeply here. Let's see the log function. This was actually removed from the V8 example as well. Never mind all the implementation, let's just focus on the printf. So I'm reading all the arguments and just printf. So I don't know, I started like on high school, and this was, I think, the first command I've ever seen in my life. I was like, oh my God, this is used in everywhere. This is nice. Okay, so as I was showing you on the diagram, here I can use the print and say, whenever I have this keyword, call my print that is here on C++, and keep doing whatever you want. write on our code, and after doing everything, we should actually check what is on V8. And I was telling you, everything that is grammar, how JavaScript works. So I can use like the eval, I can use date there to check isostring. I can use even complex types, template strings, the spread operator, async await, promises are all JavaScript, all V8. Everything that is going to be the language is the V8 responsibility. And then we can see that everything works here, all right? However, just a bit of spoiler, if you're just using a promise, this is not asynchronous. I'm gonna show you that the promise is just a wrapper for a callback function. Oh, all right. It's a lot of things, right? So I think a lot of people is gonna go like on Monday, do you know JavaScript doesn't have set timeout? Like a mad scientist. Set timeout, set interval. So let's check this out. So I created a class here. I have all this implementation for you in the end of the presentation as well. But see, C++ side, I'm receiving all the values from the JavaScript side. I'm grabbing the sleep and the interval. So internally, we usually use only one function to do both set timeout and set interval. The only thing that changes is the numbers that will go there. And we have the callback function that we got from JavaScript. So here, as I'm trying to use in the future, so I'm scheduling a function that's gonna be executed in 1 second, 2 seconds, I have to save it in memory, I would say, and then schedule using the UV. And see, it's a very simple API, right? Looking at this code. We have just timer init and timer start. And I send my callback, which is the C++ function that's gonna be executed when the set timeout ends, the sleep, and the interval. And here, we can see the UV, which is our while loop that was saying, oh, this is gonna check all the events and just dispatch them all if you want to. And then we keep the whole process. We compile to C++ instances, we get the result. If you want to print, you can print as well, and then we can call the wait for events. If we look at the code, oops. If we look at the code of the set timeout, it's exactly the same thing we've done to our print, right? So we put there the set timeout, which is the text we're gonna use, and the function I'm gonna call it. Nice, and in the JavaScript side, I have actually the whole code that we usually have there. So I have the timeout, I just changed the order of the parameters here to use timeout, but see, my promise object here is just a wrapper, so I can use async and await as all the runtimes do. So if I try running this, I implemented the set timeout, the print, and almost every core feature there. And notice, if you go to the Node.js on the first version, this is how the first version was delivered. We have the exposed class there, which is the timer, and we can use very similar to what we've done. So JavaScript follows ECMAScript specs. Everything on V8 goes from ECMAScript specs. Anything apart of this, it's part of the environment. It's a part of where your JavaScript is running. So you might think, okay, but there are a lot of runtimes appearing and some competition, some gossip about there, right? So I'm gonna talk about some similarities. First of all, Deno. Is anyone working here with Deno? Nice. Looking at the source code, I would see the same thing. We have a code that calls a script. We have the compile, it's in Rust, right? But here, they are compiling the whole JavaScript string to Rust instances and then executing, and then evaluating. The same idea. And then you can see on the execute script, they are injecting their own implementation and working with it. All right, what about Bun? Well, in Bun, they follow the exact same idea, but I think they are a bit more mad scientists, right? Because they're using JavaScript core, which the docs is really crazy to see, and they are using Zig, which is the programming language behind this. All right, we have a lot of runtimes, but why should I use Node? Why should I use Den? if they are just extending V8, right? In the end, they are just injecting functions there. Well, what makes one runtime better than others is the implementation of these C++ functions. Look at this code. We have all the functions Node.js exports for FS, which is the file system, how you read files or handle files right there. And C, it's a very complex code, right? But they are handling buffers. They are trying to check how the variables are there, how the text is coming out from the operating system. So what makes one faster than others is how this object, how these messages are being consumed and how they are being processed. So this is wonderful to think how they are working. And in my opinion, what makes one application, one program better than other is developer experience, right? Because of all these runtimes appearing, Node.js has evolving a lot. So now we have a new test runner, we have some importing, some things, we have actually a performance group to make it faster. So it's very nice. So all this, it's great. And it's not actually competition, right? So see, Jared just joined the Node.js organization to collaborate with some ideas that he had on Bun. And Colin has been working with Node.js for a while. And then he joined Deno to collaborate and still has been collaborating to Node.js. So you get good ideas from on one side and put in another. So this is magnificent, right? You can see how our ecosystem is evolving because of these new tools. And because of this, we have a working group that is made to collaborate, right? To share all this with all the runtimes. Well, I strongly recommend you going there and do the step-by-step. I actually put a Git pod with all the binaries, so you only have to take care about the code. You can extend, you can add your FS or your Magic applications as well. If you want to see more content, more additional information, go to my website. I put all the conferences I've been doing there. I also released a JavaScript string course. If you want to learn more deeply about Node.js, you can go there as well. And before finishing, I have just 2 minutes. So let's just do as a tradition. So let's make, this is gonna be wide. Let's make the other track envy, right? So I'm gonna count on 3 and I'm gonna make some noise, right? So go with me. I'm gonna trust you, right? So, oops. So 1, 2, 3. Hey! Thank you so much for having me.